Thomas. Are you speaking, Thomas?
Yeah, you hear me now because I was speaking, but I believe there was no connection. Sorry about that. I'm restarting now. Okay, so good morning. Welcome to this BDVe webinar series. Today we will be showcasing the use of big data in the transport and logistic domains. But before that, allow me to say a few words about the webinar series. So this webinar is part of a series where we will be inviting speakers from research projects and other organizations to talk about their particular experience working with big data. In case you believe you have a topic of interest, I would like to also, and you would like to be a speaker also one of our webinars, I take this opportunity also to invite you to contact me anytime to give me the idea of what you want to speak, and I can contact you later to see if we can do something together. So basically, the goal of these webinars is to show the value of big data, both from the technical and business perspectives, as well as touching some other topics of interest for our communities, such as privacy, security, data democratization, GDPR, as you can see here. This will be taken as topics in next webinars. You have also here the link to our webinars main page in the BDVe website. We will run at least one webinar per month, more commonly on the first or second Tuesday each month. So some housekeeping rules before jumping into the webinar. Please, if you have any question, write the question in the chat. At the end of the presentation, the speaker will answer to your questions, and if there's no time for that, we will provide the answers offline to the community. I'm going to ask you a couple of questions now, a kind of poll to check the main interest of the audience today, and to provide some feedback to our speakers. And you will have also a brief survey at the end of the webinar, just to get your feedback and recommendation for future webinars. So the first question today is about your interest, and allow me just to open the poll. So it's your interest in big data. So I will be launching the poll. You can answer during a few seconds, and I will collect the answers afterwards. So you are now prompted with the poll. If you start to answer, if you are more interested on technical or in business aspects, I will open this for a few seconds and then give you an overview of what you said. So allow me to check a few more seconds. Okay, I'm closing now the poll. So apparently, most of the people, around 60%, are the more technically oriented. So they are more. You are more onto the technical aspect, and 40% on business aspects. And the second question and last is the launch now, and it's about if your organization works or is most interested in this particular domain or more horizontal. Okay, you're answering now. And from what I get here is around 50-50. Is okay, and closing. So around 45% are most interested in transport, while 55% is more horizontal. So this is for you also to understand the type of audience that we have today. So allow me then to jump directly to this particular webinar. So I'm going to give the floor to our two speakers today. We have Andreas Metzer and Tony Belling that will be taking us to the work that they have been doing in the transforming transport, both in terms of let's say technical aspects and also business-oriented aspects. So Andreas, the floor is yours. Allow me just to give you control. Just 1 second. So Andreas, you should have the control now.
Very good. Thank you very much, Thomas. Welcome everybody to this webinar about transforming transport. I hope you can hear me all right. You can confirm, Thomas?
Yes.
Okay, perfect. Okay, so this will be a split kind of webinar between myself, Andreas, and Tony. I will try to give you an overview of the project, drilling a little bit down into some interesting innovations which touch on some of the technical solutions we pursued. And then Tony will take over and look more at the innovation and business side of things, and also how this can be multiplied, followed up with other external stakeholders. As you can see from this agenda I show you on the screen, is we envisioned a brief question and answer session after each of these two presentations, but we can also be flexible and move the discussion more towards the end depending on your interest. Okay, let me quickly introduce you to Transforming Transport, or TT for short. TT is a large-scale pilot action as part of the Horizon 2020 Big Data Value PPP. And as Thomas also introduced, it's part of the Big Data Value ecosystem, in particular part of the Big Data Value Public-Private Partnership. The main aim of TT was to demonstrate in realistic and measurable ways the transformation that are possible when you introduce big data technology, big data analytics, visualization, and so forth to the mobility and logistics sector. And we do this with an excellent consortium of 48 members across Europe. These are members that range from members in the ICT or software domain, two members which are actual end users who are from the transport sector, who deliver transport solutions, who are transport infrastructure providers, and finally also include research institutes across the whole range from software, big data to the actual transport domain. This looks like a rather large consortium, and I say in a minute a little bit about how we manage this and how we kind of focus the resources and also made sure the project outcomes are delivered. We set out to cover all the main transport domains which are relevant to Europe. And as you can see, it's 7 domains altogether, starting from highways, going to airports, ports, harbors, rail, connected vehicles, urban mobility, and also then the more complex supply networks involving all the different transport areas. This is quite interesting because all of these different domains have different concerns, different kinds of data available. So we can really also learn from each other across these different transport domains. At the point in time, and TT will run until summer this year, we have collected 160 data assets or data sets, which come up to volume of 164 terabyte. So this may not necessarily sound super impressive from the big data point of view, but what we realized is much more interesting in this domain is the variety of data instead of the volume of the data. So if you can start cross-correlating different data sources, this provides interesting value. You can connect data along the different transport chains and processes that provides additional value. As one of the important project outcomes, we have a so-called data portal where you will find all the metadata of the data assets we used. Some of them are open data, some of them are closed and confidential, but in any case, you know what data assets we have, and you also are able to contact the data owners in case you're interested in maybe exploring the opportunity to use the data. Okay, very briefly about the methodology, as I indicated, because this could be an interesting lesson learned in general, also for other kinds of projects of this nature. So at the very beginning, we realized that, of course, each of the domains, each of the data sets or data assets available, each of the use cases which are relevant to the domain are different. Many of the stakeholders already had a diversity of data sources and also different infrastructures going on already, not necessarily for the purpose of big data analytics and decision making, but more for some other purposes, because some of the equipment was already instrumented with additional sensors. So there was a really bulk of data which lied unused. And of course, we understood that if you have a good analytical model, this may not work in the same way if you transfer it to another domain or another use case. So we said, okay, let's in a kind take into account this diversity and make the best use out of it. So this means all the 13 pilots we have in TT in these 7 domains were able to choose the analytic solutions they thought were best suited for their requirements and data, the infrastructure they already had or they deemed most suitable, and also the big data pipelines that are kind of adopted in a way that was fit for purpose. So we started really with, you could say, a project of 13 smaller projects inside. pushing forwards to innovation, proof of concepts very early. And we're now in a stage where we start collecting these lessons learned, which we already kind of discussed during the course of the project, because we shared best practices, architecture patterns, we had a very stringent regime of KPI collection and measurement. And we now kind of leverage what was common across all these different areas, and will produce by end of summer kind of recommendation document that gives you indications on how to use big data solutions for the transport domain, but also beyond the transport domain. To do this, we also had a kind of incremental approach, a so-called three-stage validation and scale-up approach, which looked at different ways on how the solutions were embedded in the productive environment. So how much you involve the actual end users in testing and using the solutions, and also what kind of scale of data you used. So this started very early in month 6 with the technology validation, understanding the problem, playing with some of the key ideas, using the existing historic data to demonstrate what's possible. Then we moved to the large-scale experiments phase, which was closed end of last year. Still in a controlled environment, not yet the productive environment, but already including real-time data from the field. And now we're in the final stage of this methodology, which we called in situ or on-site trials, where we now involve end users using the solutions, for example, the decision-making support, the visualization support in parallel to the daily use, and collect feedback from what it really helps them in doing their daily business. Just to give you a feeling of what came out of this project, because it's not possible to explain all the innovations we had in this very short time. You can see here the main dimensions along which Transforming Transport delivered innovations. The first is improved operational efficiency, making processes more efficient, less resource intensive, delivering better customer experience, and of course, in the last important point, also delivering new business models enabled by big data and digital technologies. And I'll not go into detail on that. Here you see the different domains and how much they kind of contributed to the various areas, so how many innovations, in a sense, they had in these various areas. And what you can clearly see is that, of course, the operational efficiency was the most focused, because it's also the, let's say, most obvious, because transport is a quite old domain with many opportunities for improving efficiency, with many things where you immediately see what can be done better. So in the ports, you're talking about 30% opportunity for efficiency improvement, for example, because things were done manually over so many years in the back. If you're interested in more details, here's a link to the deliverables of TT, and you will find the stage 3 results, as I just mentioned on the slide before, in the deliverables 4.3, 5.3, up to 10.3 for each of the domains. It's a summary of the actual results, because most of them are confidential, but what you will find in these documents are also the contact points of the owners of the pilots, so you can contact the people in case you really want to get engaged and find more about some more details. Nevertheless, I'll be able to kind of demonstrate very few, let's say, tangible examples from the various pilots we have, demonstrating the innovations in these various domains. So the first is predictive analytics for proactive terminal process management, which we explored in the Duisburg inland port terminal. It's one of the largest inland ports in the world. And the problem is they cannot grow in size, because in the middle of a city, so they have to be more efficient, obviously. And how to do that? They started with very simple means to visualize what goes on in the terminal. So all of the machinery in the terminal is nowadays digitized and sensorized, so they could use this to get a good visualization of what goes on and see some bottlenecks. Second level was then also to introduce some decision support for the terminal operators, delivering risk and reliability for warnings that maybe there's a delay, a problem on the terminal. And the final thing, which I'll illustrate in a little more, is we used some advanced analytics, in particular deep learning, for proactive terminal management to anticipate future problems and able to deliver proactive actions to mitigate or avoid these problems. So to do this, we had access to the data streams of a fully digitized terminal. You see here on the left-hand side of the slide. And basically, we got data from the cranes here, from these little things called reach stackers from the trucks and also from the trains running here on the tracks. So altogether, this is 1.3 million states per month, meaning positions of equipment in the terminal. And from this, in the first data integration and aggregation step, we were able to compute so-called moves, so where starting point, end point of a container is when it changes the transport means. And first immediate results was, as you can see on the right-hand side, the heat map showing you where the containers are typically moved and stored. And on the upper left corner, you see that there may be some opportunity for storing more containers or better distributing the other containers. So this was one of the first observations we had when using this data in a kind of descriptive way. Moving from there, the ambition was to do this proactive terminal management. And what you see here on the left-hand side is a very short snip from the cockpit we delivered as part of this pilot. Here you see the different trains in the terminal, including their scheduled departure time and also then the predicted departure time. And in the case for Gothenburg, you clearly see there's a delay. This will be roughly 1 hour later than planned. So here you have a problem. Here you may want to do some proactive actions in order to avoid the delay of the train. To do so, quick drill down on the technicalities. We used a very, let's say, promising form of deep learning, so-called recurrent neural networks, which allow you to feed arbitrary length sequences of events into these networks. And they have a tremendous improvement in accuracy. So what you see on top of the slide is basically the different points in time when you do a prediction. Obviously, the later you do a prediction, the better. But the more important thing is the orange curve shows you the significant improvement of accuracy when you use deep learning, the recurrent neural networks, compared to shallow learning, in this case, multi-layer perceptrons. Plus, these RNNs, these recurrent neural networks, are very robust. So we tried with many different hyperparameters, different encoding of the data sets, and they always delivered relatively good results. So we never really had a huge problem, which means for practice, very nice out-of-the-box solution in a sense. Okay, next is the kind of improved, let's say, user experience. What we have here is improved driving and travel experience for the highways managed by Cintra and Ferrovial in Spain and Portugal. So what they do is they use analytic solutions to find a better distribution of the cars along the traffic corridors, because there's two alternative roads with which can be shared the cars. Better information and decision tools for the road users, so you get some feeds on your smartphone about the traffic conditions. And the last point, again, I drill down a little more, is real-time warnings about problems on the road by using a quite interesting novel sensor technology based on fiber optics. And this fiber optic solution has a kind of tremendous, let's say, interest from the big data side too. So what you see here on the left-hand side is this fiber optics cable. It's a signaling cable, which is anyways in all of the roads there to connect the different kind of control centers. And this fiber optic cable has the physical, let's say, characteristics that if there's a how you call it, impulse on the road, the light will be broken a little bit differently, and you can measure the changes in the light at the end of the fiber optics cable. So what this cable delivers is roughly 1 terabyte of 1.0 gigabyte of data per second, which is then using a rather complex analytics pipeline, clustered, classified, removing the noise from the signal. And what you get there at the end is this time distance diagram, where you may not see so much, but basically what you get here is the measurements of 3,500 virtual sensors, because every 10 meters or so you have basically this virtual sensor by measuring the fiber optics cable. And the interesting thing is what you can do now with this data, which you see on the next slide. So you see these different curves, and they actually indicate how a truck or heavy car moves along the highway. So you can measure the increase of the slope, which gives you the average speed of the truck running on the highway. You can measure or count the number of lines, which gives you the occupancy in each of these lines. And you can even do some more aggregate analytics by seeing if there's a jam, and all of a sudden this slope starts to even out. And you can also compute the waiting time along this axis. So what we did in TT so far is actually compute these charts, and we're now in the process of using deep learning again to find these patterns automatically to support the decision makers in transport operations. Okay, final point, new business models, data-driven decision-making in retailing at the Athens International Airport. A little side note, 60% of the revenue of airports is now coming from retail and not anymore from the actual planes. So there's a huge interest in improving the retail operations let's just jump to that important point, by really adapting the marketing to the passenger typology per time slot. So they're thinking of really targeted advertising depending on which plane is arriving at which gate, up to using really insights of the data to find niches on specific customers. So we're getting there a little bit more into the kind of Google world and Amazon world of Europe. Okay, conclusion. Opportunities. I think this deep learning, recurrent neural networks have a tremendous opportunity. We have huge data sets now, so we can feed these advanced machine learning solutions with this huge data set and delivering really good out-of-the-box solutions. There's a tremendous opportunity for data sharing because, as I said at the beginning, due to the variety of data, connecting the different data sets to kind of build the whole transport chain delivers much more opportunities to manage the whole transport sector. Of course, we face some challenges. One which immediately comes to mind is data protection. But interestingly, maybe in other domains, like let's say healthcare, for example, the personal data amount is not so huge. So in TT at the beginning, it with 1% of personal data, which we're able now to actually reduce to 0% by anonymizing some of the things. And you can still manage the transport very, very good without this personal data. However, on the other hand, you have lots of commercial data. So this is the more critical thing in this domain, at least to our observation. Final point, I think everybody shares this in a sense, the lack of skills. This is where I kind of close the loop to the BDVe again. We have a huge lack of skills of data professionals that really take these innovations and really put them to scale. And the BDVe PPP has started to contribute to that, for example, with a portal on big data professional education programs to train people further. And with that, thank you very much so far. And I guess we can open the floor to questions if there are any.
Yeah, I think so far there's no question posted in the chat. So I remind you that any question that you want to post can be later answered by the speakers. So Andreas, I think thank you very much. I think that you can maybe answer later if there's a question related to you.
Absolutely. Yeah.
If anybody wants to ask a question to Andreas, just mark that this is for Andreas or for Tony later. Okay. So without any more delay, I'm going to pass the floor to Tony. So Tony, in principle, you have the floor is yours to start. Okay.
Okay, can you see my screen?
Yes, we can.
Wait, I put in.
But it's not in presentation mode.
Yeah, I'm going to do that now. Okay. Good morning. Thanks to Thomas to organize this webinar, and thanks to Andreas always to provide very good insight of TT. Okay, I'm going to talk about innovation and business. We have two companies working on this in TT, company Atos and ourselves. And I'm going to show you where we are, what we have done so far, and what are the future steps, future work to perform, okay, till the end of the project in June. Activities, we adopted a strategy that we call from local to project and from project to global. What does this mean? We have some pilots, as Andreas mentioned, 13 pilots. And for each of the pilots, we have identified what are the innovations that are available outside TT that could be fruitful or could bring some benefit to the pilots that we are developing, okay? So we have been browsing any kind of innovations implemented by SMEs, entrepreneurs, funded by, European incubators, accelerators, SME instruments, and venture capitalists. So what are the innovations in place that could be of use for a TT? That made the pilots even better when they are delivered on the market. Okay. At the same time, we offer this innovation coming from outside a kind of a big window at European level, a showcase where they can also sell their innovations thanks to the TT project. And the second part of the strategy is we've got these innovations that we are developing, and we want to facilitate the market take-up of these innovations on the market. So we have been developing innovation, we've got new services. How are we going to make that available on the market? How are we going to make this profitable for the companies that have been developing those innovations? So as part of this strategy, we have to establish some agreements, cooperations, contracts between the pilots and customers, people buying the solution, and also with investors. That means people ready to fund on the innovations to improve the innovation and also to take up these innovations to market. Okay. In between, we have got two major activities. One is the market impact and stakeholder mapping, and the other one is the pilot domain exploitation. So in the market impact, what we do is a famous STP strategy. So we segment the market, then we target, which means part of the market, which part of the market, big market is interesting for us. And then what is the positioning? So how are we going to position ourselves in the market segment? We identify what are the benefits delivered by our innovations and who are the market competitors. Second step is to identify in each pilot domain who are the stakeholders. So who are they? How do they interact with each other? Then to provide with a business development strategy to commercialize the results. So I will give some examples later on. On the way on, before the end of the project and after the end of the project, we have to take care of what we have in hands, what are the exploitable assets or products, and continuously refine the products, so the definition of the products and their characteristics. We classify them through the TRL, so the test readiness level. So we evaluate the maturity of the technology just to attract some customers and some investors. And then we identify some mechanisms to exploit the innovation provided by all the TT domains. Okay, so we are just doing that right now. Okay, so coming back to the first activity from local to project, it consists of identifying what are the pilots, what are the objectives, what are the main innovations and plan to provide to the market, and what is the impact on the big data landscape. So what is the new innovations, what are the stuff we are bringing to big data. So the strategy here has been to identify sources of information for each pilot, so web, journals, magazines, conferences, and so on. And who are the relevant actors and stakeholders working on these similar objectives. Like, for example, if we take railways, so what are the press conference journals talking about railways, transport, and who are the main actors in railways. Okay. Then we send the information to the pilot every 2 weeks, and then we get feedback from the stakeholders, from our pilots. Sorry, and we iterate with them. So, are you interested in getting in touch with this innovation brought in the market outside of the TT project? And if yes, then we provide them some more information, and we put them in touch with these innovations and with people working on the transport domain outside of TT. Okay. So as a result, so far we have been generating databases based on Excel. We made 6 iterations of the databases, and they're all available on our online database and project. And the database are really full. We are quite happy with this. We have more than 450 sources of information that have been shown on this slide. So you can see all the pilots from highways, cars, trucks, railways, ports, airports, human mobility and dynamic support network. That means the logistics. And for each, let's say, topic, you have the number of sources of information we've been able to identify. Okay. For example, for the railways led by Thales, If you see the columns, I've got the main objectives identified, what are the objectives of the railway pilots, what are the main innovations brought by the pilots, so what is really new from what it was before TT, what is the impact of big data, which is really the scope of the project, why big data is important for the pilots, what do we bring to big data environment in European landscape, and what are the results expected and benefits expected for each innovation. Okay. So we did that for all of the pilots. I'll give you also another example of what are the websites and newsletters and conference workshops that have been identified still for the railway pilots, or sources of information, data sources, and stakeholders who is working on the railway in Europe, so SME, European project connected to railways, venture capitalists, European technology platform, European initiative working on railways. Okay. And then who are the actors working on railways? So all of this information has been compiled, sent to the pilots, and we're iterating together with them to identify which of the information is of interest to them, so that they can sign some agreement with external stakeholders. Okay. Second part is we have got now the pilots, we develop them, and we want to get them global, so we want to uptake them to the market. So we define the market sector, the strategy. We refine the products for each market. This is what we are doing in collaboration with Atos. And then once we have identified the stakeholders, so who could be interested in replicating the solution, the innovation, who could be interested to use or to buy the solution, then we identify the stakeholders, we send them information, and then we monitor. Okay. We constantly then send them information about the pilots, and if they are interested, then we help the pilot to set up deals. Okay, this is where we are at the current stage of the project. Okay. So to summarize this project to global, we are currently developing this go-to-market strategy in Canvas, and together with the identification of main competitors, and then we identify the stakeholders, we communicate with them, and hopefully we establish agreements for commercialization of the innovations. Okay. So this is a summary of what we are going to do next week in Madrid. I've got the general meeting of TT to address this go-to-market strategy. The objective is to translate the product into a business plan. So what is a product and how we can transfer this product into a business plan, where we characterize a segment of the customer, what are the needs of the customer, who are the competitors, what is the unique value proposition of our innovation, what are the advantage and the cost structure. Hopefully next week we'll be available, we'll be ready to start to define the cost structure of the service we are going to provide, the metrics for the success of the deployment, and the revenue streams. Okay. Then from inside, from local to project and from project to global, we've got this definition of the market impact, where we have different steps to follow. So first, we identify the key stakeholders. What is the influence and what is the importance? So for each pilot, we make this analysis. Who are the stakeholders involved? We make a mapping and establish a relationship between all the stakeholders, and then we address what are the benefits, quantitative and qualitative. Okay. And then we have finally the overview of the market competitors. So I'll give you some examples about what we do for this stakeholder mapping. For example, this is for the work package 5, which is for connected vehicles, cars and trucks. These are the kind of stakeholders we are taking care of. So industrial data providers, car manufacturers, food industry. We've got the category of the end users, vehicle owners, drivers, the intelligent traffic system, infrastructure providers. So who are they? The providers, telecom operators, the service providers for the vehicle, fleet management system, navigation system, financial services, and the public authorities. So the European Union, the regulatory bodies, national governments, public transport operators. So this is a classification of stakeholders for the work package for the pilot on connected vehicles. I'll give you another example. This is for ports. Okay, so here again, we've got different kind of stakeholders: port customers, port infrastructure suppliers, terminal operators, port authorities, innovation research. Okay, I'm not going to name all of them, but this is just to give you a kind of overview about what we do when we identify the key stakeholders. Okay. And this is for the airport. Okay, so airport customers, infrastructure suppliers, retailing, as Andreas mentioned before, very important today. Airport management and operations, and airport authorities. Okay. Now we've got identification of all the stakeholders and how do they work together. So this is a second step, which is a mapping of the stakeholders and the relationship between them. So you can see the arrows here. They've got different colors because each of the colors represent a kind of flow of data. They've got the knowledge, the monitoring, the technology, the data information, services, and the policy. So this is very useful to understand the mechanism about the flows of the data and the relationship between the stakeholders, because all of them have got an interest, and it's very useful for us as innovation developer to understand how this works to better address the needs for each of them. Okay, that was for it was for connected vehicles. This one is for highways. So you see here different stakeholders again. So institutional, regulatory, and policymakers. For national government, Junta de Andalucía, which is a region in the south of Spain. You've got research stakeholders. You've got service provider stakeholders, PPP, entity, the toll customers, and company staff. Okay, so how they work together helps us to understand how we're going to be in the best position to sell. Okay. The analysis of benefits, quantitative, qualitative. First, qualitative, of course, as mentioned by Andreas before, we were looking at, let's say, using less resources and be more efficient. So this is kind of a qualitative benefit we have as part of the project. We see here for the logistics, dynamic supply networks, increased efficiency and delivery planning, offering better customer service, enhancing trust and loyalty given by the continuous feedback collected by logistic providers. Okay, that's all qualitative. But then if we talk about quantitative, then we put figures. We put figures because we want, for example, to improve the forecast accuracy of returns by 47.5% and so on. Okay, so that's the kind of benefits our solutions can bring to the market. Okay, we are really able to do that as part of the TT project. Then the last step is about market catalyzation. We are currently doing that. So IP protection, degree of innovation, and unique selling points. We will be able to identify the assets of each pilot through tables. Okay, the main features of each product, each services, what is the IP protection for each services, and what is the initial insight about the market situation, so where we are. We classify each innovation by its TRL, so technology readiness level, and then we start the mechanism to exploit each TT pilot domain. Okay. So an example of a table of assets for ports, for example. So who is the target market? Port terminal operation managers. What is the added value? So we want to have a software that doesn't deal as it deals today only with taking care of historical data. We want to have a software that provides us with trends and using analytical models. So what will be the future, not only the past. The benefits of the innovation, time to market, the IPR, so the protection intellectual property of the innovation, how we are going to disseminate and who are the partners involved. So we will have a kind of table like this for each of the pilots. In fact, we already have. So far, the results of TT. So far, we have produced 22 commercial assets, which is quite a lot. They are mainly software. Okay. They are new or enhanced products because some pilots that didn't start from scratch, but they had already some kind of solutions before TT and they have been enhancing their solutions, but some also are really new. all involve big data capabilities. Okay. And together with these 22 commercial assets, we also have 4 non-commercial assets that I will show right now. You can get access to the innovations through the innovation radar by the Commission. I'll give you here the web page. I guess you know this already. If you put Transforming Transport, it shows 24, but really there are 2 that are not part of TT. The other 22, they are part of TT, so you have got a list of all of them. And as I said before, it's mainly software, so I put here a list of what we have been able to develop as part of TT in terms of software. I don't go through all of them, but you see it's quite impressive what we've been doing. In fact, I think the Commission is quite happy. We got very good results at the last review in September. So software. And what is interesting to know and to understand is that how we match each of the assets, each of the innovation versus big data analysis. Okay, so where we provide with hints, with enhancements, with improvement in the field of big data. Okay. So for each of them as well, we've got this kind of table where we are able to demonstrate that, look, this innovation is working in this specific field or subfield of big data. Okay. In hardware, 2 innovations, and we've got also 4 services that are also assets provided by TT. So they are all in the innovation radar. And then non-commercial assets, there are 4 called knowledge, research publications, and descriptive mobility patterns. We've got the framework developed by UPM and Atos, about the KPI evaluation framework. We spent quite a lot of effort in defining the KPIs, the key performance indicators. And we've got also the open data platform by UPM. Next steps of TT. We are implementing this go-to-market strategy using the Link Canvas business model. It will happen next week in Madrid. We are still identifying the main competitors of each of the innovation. We have started communicating with the stakeholders to try to sell the innovation and the output of the project. And we are in the process also of establishing agreements with potential customers or potential investors. Okay. To disseminate TT innovation, I just wanted to give you some information about this support action, BDVe project, which is support action to support the implementation of the Big Data Value PPP, so all the projects. Inside this portal, you have got a marketplace that is ready or almost ready, where everybody can deliver its innovations. It's even if you have yourself innovations in your companies that are related to big data or data-driven economy, I would suggest you to have a look at this and to publish it. The purpose of this marketplace is twofold. Is to publish innovations, so the offer, to attract the demand side from potential customers. So I've been able to do this. I would like to sell it on the market, and who are the possible customers interested in buying my solution. So it's really a commercial link, let's say, for you. And then the other area where the marketplace is very useful is to attract potential customers. So who is interested in investing into innovations delivered by TT to improve the innovation, current results, or to help the innovation if it is attractive for the investors, and to help them to get financial support to go to the market. Okay, so I suggest you strongly to have a look at this bigdatavalue.eu and the marketplace in particular. Now I'm finishing. I would like you to give you some hints about how you can collaborate with us. We are still happy to collaborate with projects and customers and stakeholders. So you have our website. I've got 2 email addresses, support and communication from the project. For the technical issues, you can contact Andreas. And for the business and innovation issues, you can contact Victor Corral from Atos, or you can contact my team at the following address, email address. That's all from my side. Thomas, I don't know if you have something to say or.
Yeah, thank you very much, Tony. I think it has been two very interesting presentations about TT. And now I think the floor is open to questions. I have already one from Hala. You can also, by the way, can raise your hand if you don't want to write the question. You can raise your hand using this facility of the tool, and I can give you the voice if you want to speak up. Otherwise, you can write your question directly. So Hala, apart from writing a question, she also raised her hand. So if you like, I can unmute you, Hala. Just 1 second. No, I think she's not there now to be unmute. So allow me then to just read the question directly to you. I think it's a question for Andreas, and it's the following. Do you also consider using big data for testing and validation of automated driving systems?
No, we don't, but we are very much engaged with colleagues from the autopilot, large-scale pilot action from the IoT unit, because they do all this autonomous driving. And in fact, we have also a shared use case as part of one of our pilots together with them. So it's a kind of separation of concerns. We don't touch the autonomous driving, but we still exchange lessons learned among the two projects. So it's the autopilot project in the IoT area.
Okay, thanks. I have also, there's no more question for the audience so far, but I have a couple of questions also for you as we have time. So one of them, I think you mentioned that you are collecting also best practices and lessons learned. And I think it's both from the technical but also from the business perspective. So when do you think that we will have this collectives and how we can access to these particular things? Because I think the project can show very interesting outcomes and it's very interesting for the audience.
So we're currently indeed kicking off this final process of aggregating the lessons learned, condensing them, distilling them into the final project documents that should be delivered end of summer. But of course, you can already go to the website and check some of the deliverables where you can find how we did things, what were the kind of insights from the data, descriptive data analytics, what were the data pipelines we used, what were the key outcomes with respect to the objectives. So for the individual pilots, you have this in a sense a little bit already there, but we're now doing it in an aggregated form, both for the domains. So you will get a kind of document explaining what may be the impact in airports or ports or something. And then we will have a very high level document distilling the results further into really general recommendations. But this is the process we will indeed start next week in our next meeting in Madrid, and then deliver this by summer, around summer.
Okay, thank you very much. Also, Tony mentioned the marketplace in BDVe. Just a precision from the BDVe side, because the marketplace is right now ready, but is not populated. So if you go to that URL, you will see the status, but not really assets. But this is something that the project will be doing in the next couple of months, and that's why also Tony asked for your help in case you are in a project or you are in an organization that would like to have your product or your result into the marketplace. It will be very welcome, and you can contact Tony or myself or anybody from the BDVe project. That's as Tony was saying. And just probably the last question also for Tony. So what is your impression after these 2.5 years, I guess, or 2 years of the project right now, about the use of big data into this particular domain? Is really helping the organizations? It has been some blocking issues that didn't allow in some of the specific pilots to go further, or something that you can share at this point?
It's a question more for Andreas and for me, but I can talk about my pilot, which is connected cars. So the purpose of TT was to assess the value of big data for the domain of transport. If big data was a buzzword, for transport, if big data was really something that could help a transport domain to be more successful. I can talk about what I know from the pilots I've been talking to, and also in terms of the business and innovation. I think big data really has got a value. There's no doubt that it is going to be very useful. It has been useful and will be useful. And I'm not a reviewer of the TT project, but I'm sure the project will be very successful. So in terms of cars, connected cars, then ourselves we work on the connected cars, and what we do is to different things. We try to assess behavior of the driver. So what is the capacity of the driver to really drive properly the car. We also work on the predictive maintenance of the car, so how big data can help us to identify potential failures in the car, taking into account data from various databases. And of course, we focus on the CO2 reduction, and we provide with data for the management of the traffic. So for us, definitely for the cars, it's very, very, very useful. And maybe Andreas can comment on some other pilots where big data has been successful.
Yeah, I fully agree with your observation, Tony. It's the successes, I think, in two directions. I mean, the first is that we had a couple of pilots who were very confident that there will be value in data, and in a sense, they were now able to really get concrete figures on how much value is there, how much improvement in efficiency, for example. But we also had quite a couple of pilots, or at least end users in the pilots, who were rather skeptical about whether big data has any value at all. And we now saw a quite interesting mindset that, as you probably saw in this very simple example with the Duisport pilot, that already visualizing the data you have in a good way with this heat map, for example, already opened the eyes that they would see things they have not been able to see before. So many of these skepticisms have been kind of helped to even out. And this also led to a mindset in how organizations collect and manage data. So all of a sudden, data for them has more value per se because they know they can distill findings out of the data. Whereas in the past, they may have been able to have the access to data, but they just didn't care in a sense. Now it has changed, and this is also important from the data quality point of view, because as soon as you have a clear purpose for what you want to do with the data, you also understand that data quality is important, and you may take more care in collecting data in the first place. So this was a really interesting observation on the quite a more higher level.
Okay, thank you very much. I think there's no more questions so far from the audience. So I'm going to close the webinar. Thank you very much for attending the webinar. The recording and the presentations will be uploaded to the BDVe website. So you will be able to see it again, or to check the slides and check for the pointers that you have there. So again, thank you very much, and you will be posted with the next webinars also in the webpage and via our normal channels. So thanks again, and goodbye. Thank you for attending.
Thank you for joining.
Bye-bye.
Bye-bye.
Bye-bye.